Okay. All right, let's do I'll clip it, or I'll do a highlight from here, and then I'll just like try to quickly explain how this game works. Say, hey everybody, hey people at the start of the highlight. This is I took my crazy game that I made earlier and I turned it into a shoot 'em up. So we got this butterfly boss, and let's go. So the butterfly boss has infinite HP, so we're just trying to shoot it as much as we can. And you can see in the top left corner we're getting points as we shoot it. So if I go over here, you see I'm not getting points anymore, right? So the goal is to get as high of a score as you can before the boss takes you out. Let's see how high we can go. If you look at the way the arrows are coming out of those 4 different locations, after I get obliterated by the boss, I'm going to okay, we're good. So after I lose to this boss, I'm gonna show how I made these arrow patterns. Oh boy. Oh, I'm dead. Well, now that I'm gone, I can explain things. So the way I did this, there's a lot to explain. Let's do the boss movement first. There's an object that's randomly bouncing around about this area of the screen, and every 5 seconds the boss will glide towards the object's position. That's how I get it to move randomly in about a box about this big. Now how I get the object to teleport in this box is really stupidly convoluted. In fact, now that I think about it, it's pretty stupid. It's really stupid now that I think about it. You know what? Hold on, let me see inside. Let's change that. So just call this boss move and target. All we're gonna do is just give me a wait so we're not doing this constantly. Maybe every second or so. Oh, let's do it every 5 seconds. Just when the boss targets me. We're going to set X coordinate to a random position. Oh, let's do this. Set this to a random position. You know what? Just to be safe, let's do every 4 seconds. What's some good X coordinates? Where are you at? Oh, ignore that. Ignore that. So that's the farthest I wanna. Maybe so 0's the middle. Maybe about -60. Yeah, that seems pretty good. Pick a random. So -60 to 60. There. Okay. So all this now this ball will do if we don't hide it. See if I show it like this, you can see it's just going to teleport around them, and the boss will move to that position every 5 seconds. Yeah, so that's all it does, just teleports around and the boss moves towards it. Yeah, so that's how we make the boss move. Nice and simple. I had a really, really dumb system earlier, don't worry about it. Don't worry about the giant basketball. Okay, so that's how the boss movement works. Let's look at okay, let me start this again. All right, so this is a shoot 'em up game that I made in Scratch by MIT. After this little demo here, I'll explain how the game works, and kind of my goal with this is that if you've never done game development before and you're interested in it, especially if you don't know how to code yet, or even if you do, Scratch is a thing that lets you make games like this without doing any code at all, which is really nice. So I'll explain. This is maybe more of an advanced game that I've made. I have a simpler one called Crazy Game in my projects, if you want to check it out. This one's more complicated. As you can see, there's 4 different holes where these arrows are coming out of. I'm trying not to get hit by the arrows. There's a little dot in the center of me, and if that little dot gets touched if it touches an arrow, I lose. And every time I shoot the boss with these little bread sticks, I get a point for shooting the boss. The boss has infinite HP, and it's just a contest to see how high of a score you can. Oh no. It's a contest to see how high of a score you can get before you lose. So, yeah. Every time that move sound effect happens is difficulty increasing, and it will increase 10 times. You can also tell that the sound effect pitch goes up a little bit each time. I think we might be near max difficulty now. It's kind of intended that max difficulty should be like very, very difficult because you're not supposed to last this long, which is why it's so crazy, right? It's still going up. This, I think, is max difficulty. Okay, so what we can see here is that there's these 4 locations the arrows come out of, right? The top 2 are basically doing the same thing. The bottom 2 are kind of doing the same thing. I just use different variables to make their behaviors slightly different. So I'll explain what the top 2 do, and then I'll explain what the bottom 2 are doing. But yeah, it's pretty cool to watch. Like just like even without playing, like I like looking at these things like swaying back and forth. It's pretty cool to watch. Oh, that's so cool. You know what? I can actually tell you what they're doing. So the top ones here, they fire out. Well, they're kind of firing constantly right now because it's max difficulty, but they fire volleys of 4 arrows, and they're fired in random directions, but they're kind of vaguely in the player's direction. So it'll pick the angle towards the player. I think I'm like around here still, even though I'm invisible. It'll take that angle, right? The first arrow picks a random angle that can be up to 60 degrees off. The second arrow can be up to 45 degrees off, so it's a bit of a narrower range. The third arrow is up to 30 degrees off, and the last arrow is up to 15 degrees off. So the last arrow is pretty much heading in the player's direction, and the first arrow might go in the player's direction, or it might just go in a random, like that one there, or that one there. Yeah. These smaller ones here, the smaller circles, these are more complicated, but like the way that they look, I think is really cool. So I think it was worth the complicated logic. They have an angle, first of all. The angle kind of rotates between, I think, positive and negative 60 degrees. Well, relative to down. So like here you can get to about 60 degrees this way, and then it turns around, right? Like a water sprinkler. And it's going to go over to minus 60 degrees, and it's going to turn back. And the same with this one here. The difference is that the right one is going a little bit faster than the left one. Like it's turning a little bit faster. Likewise, this guy up here, the right one is shooting arrows that move a little bit faster than the left one. You can kind of notice. So anyway, in addition to a variable that keeps track of this angle that they're shooting at, there's a whole bunch of variables for that. But the way it fires these arrows is that every like volley, it's going to look at the angle that it's got currently, and it's going to fire one arrow 3 degrees to like behind it, one arrow straight, and one arrow 3 degrees ahead. And that's how you get this like pattern. It's pretty cool. There's a little bit of math with like positive and negative integers. It's pretty cool. And I just like watching these. Okay, so let's I think that explains everything. Oh yeah, so the way the boss's movement works is really simple. There's just a basketball that gets a random position in this box, and every 5 seconds the butterfly moves towards the basketball. That's it. Okay, let's go take a look at the logic. So here's the basketball boss movement. It's invisible, and every 4 seconds it's going to teleport to a random position. So if we like actually look at where it is, seeing the butterfly moves towards it, and it's going to teleport. And the butterfly moves towards it again, and it's going to teleport again. The butterfly's going to move back over there. Yeah. So that's how movement works. The boss, so the boss kind of has a few things going on here. This thing down here is when it touches the player. Yeah, so if you run into the boss, it's just instantly lose. So that's what that does. This over here, we go to the back layer so that if for some reason you get up in the boss's grill and your sprite overlaps the boss, you'll be on top of the boss, which I think makes sense. We start in the middle, and then every 5 seconds we're going to glide towards this basketball. I think there's like better ways you could do this, but this is simple and it gets the job done. But that's, I think, something that if you wanted to make the boss movement more, because you can tell like sometimes it moves really slowly and other times it moves at what I would consider the correct speed, a much more gentle, faster speed. So if you want to like modify this so it always moves at that gentle speed and not uber slow speed, that would be an interesting challenge. I think that would be It'd be interesting. There's more than one way to do it, I think. And yeah, definitely, you can definitely try that out. But I think that's kind of if you're just starting game programming, that might be a little bit tricky. But you know, it's an option for later. Okay, finally we have, this increases the difficulty. So what we have here, you know what? I'm actually gonna add comments to these. Increase difficulty. There we go. Okay, this one we're gonna say add a comment. Collides with player. And this thing's comment up here will be movement. There we go. There we go. Okay, so the way we increase difficulty is we have two variables that control difficulty. Bullet speed multiplier. The higher this goes, the faster the bullets go. And bullet long cooldown divisor. So there's a variable in each of these 4 arrows called the long cooldown. That's basically the weight, like the weight. See, there's a volley, there's another volley. So the long cooldown is the delay between these volleys of bullets. And this divisor divides that. So the bigger this divisor gets, the shorter that quote unquote long cooldown is, until it gets to the point where there's like no cooldown and it's just constantly spewing bullets at you. That's when this thing goes up to 10. So you got like literally 1/10 the delay that you started out with. And the bullet speed goes up to 2, so the bullets can go up to twice as fast as they start out. So yeah, and that's all this loop does here. Oh, there's also the move sound effect. So it's gonna, every 10 seconds, we're gonna play move, and then we make things a little bit more difficult by raising these numbers. Excuse me. We're also increasing the pitch of the move sound effect, which is why it goes move. If you want to see what this game plays like at the hardest difficulty right away, you just change this wait from 10 seconds to like 0.1 seconds. There you go. Instant hardest difficulty. But let's put that back. Okay. Okay, so that's how the boss's code works. Player hitbox is pretty straightforward. Where's my player? So the little hitbox is like right in the middle there, and it always follows the player. This is something that this code is the same, or this logic is the same as my crazy game, if you want to check out that tutorial. And likewise for the player, this is all from the crazy game. So I will defer to that tutorial so you can learn how the player and the hitbox move. We added this player shot though for this game. The original copy will hide itself in case it was visible. And then whenever a clone is made, whenever the player fires a bullet, we're going to teleport to the player's location, go to the back layer so we come out from behind the player. The ghost effect makes it semi-transparent, like that, because I don't want the bullets to be too distracting. We show it, and then this glide just makes it go really high up, really fast. And then once the 2-second glide is done, it will destroy itself. But when a clone is created, if it collides with the butterfly, we give the player a point. We play a sound effect, that sound effect, and then once that sound, well, hold on. This actually should be in the other order. So what I've done here is play sound until done, means that the bullet isn't going to disappear until that sound effect is done. But we actually want to hide the bullet before that happens, just so it doesn't like collide with the butterfly twice, for instance, and give you multiple points, or like you might see it come out from behind the butterfly even though it hit the butterfly. So the first thing we should do is hide the bullet. Then we play the sound effect, and after that sound effect finishes, the clone is destroyed. So yeah, that's what happens when it hits the boss. All right, let's look. So we did the boss already. Boss's movement did. Now let's look at these arrows. So this arrow contains, each of these arrows actually contains 2 sets of logic. One set of logic is it initializes some variables, and we just follow the boss. So if I see if I reveal this arrow here, and this arrow here, and reveal this. Oh, these are like, hold on, you know what? Let's actually make these easier to see. So it's 100. Yeah, there. That makes them easier to see so you can see what's going on. So you can see that they kind of follow the boss, right? And they're in the 4 locations there. Let's reveal them again. So this is the bottom right, bottom left, top right, and top left. So you can see that, you know what? I should probably just make these things face 180 degrees, shouldn't I? That would make more sense, wouldn't it? 180. 180. There we go. That makes more sense. And point and direction. I think I can just delete this then. I hope so. All right, so now you can see what's going on a bit better. Let's do it again. So these two, they kind of follow me, right? So these 2 arrows always look at where I am. And then the bottom 2 arrows always look straight down. But you can see that they're firing bullets in different directions, and I'll get to that later. Which I guess, yeah, these might have, the bottom arrows, oh, I can still move, by the way. Even when you lose, you can move, so I can make the arrows track me. Where am I? Yeah, even though I'm dead, I can still move. Yeah. So, let's delete it. So yeah, so these ones, all right, let's explain what they do. In fact, I'm gonna let this thing play while I explain, and you can kind of see what's going on. So let's hide these for now. Let's look at this one. That's how right off the bat it's a bullet hell. Yeah. Okay, so so we got some variables here, and then this code here will always keep me pointing towards the player, and it also follows the butterfly. So as the butterfly moves, the arrow stays. See this change X and change Y? Those offsets keep it in that position. And I found that by well, you can watch earlier in the video, I guess, to see how I figured out these numbers. And then like this one here, which is up here, you can see that it's like positive 67 as opposed to negative 67. I don't know if you can see that on the stream actually. Okay, so that's what that logic does. Down here, this is the same actually as the crazy game. But to make it real quick, oh, this is new. We set the speed to our speed variable times the bullet speed multiplier. So the boss, remember, increases bullet speed multiplier over time. And so that means that my speed is going to increase over time. Okay, and something important to note is that the original copy, the big one here, has a speed of 3. But every time a clone is created, it takes that speed copy and then sets it to speed times the multiplier, which I think is 2 right now. You can actually check. Yeah, it's 2. So it's actually setting speed to 6. And the cool thing is that this clone speed will be 6, but the original copy will still keep its original speed of 3, which is really nice. So after that, the next thing this does when a clone is created is it's going to turn by this variable called angle offset. And that's controlled up here. Basically, that's why even though the arrow points at me, the tiny arrows come off in random directions because they're getting random angle offsets. So then we show the tiny arrow, we go to the front layer so that the tiny arrows are on top of the butterfly, and they'll also be on top of the player if I'm visible. You can see that the tiny arrows stay on top of me. Pretty standard for bullet games like this. And this again is from the crazy game, where it increases its size from about 1% to, what's the maximum size? Max size is 25%. So that's why you can kind of see when the arrow appears, it like gets bigger and then fires. That's what this is doing. Which I think is, I like that because especially in the crazy game, you can see the arrows appearing and what direction they're going to go in before they take off, which I like. And yeah, and then this last bit here, if the arrow touches the edge, it disappears. And if it touches the player's hitbox, which is the tiny ball inside of the player here, if it touches that, then the player is hit. And when the player is hit, they lose. So all of the arrows have this is pretty much exactly the same. In fact, yeah, the only difference here is that instead of turning to angle by angle offset, we take, see, you can see how this is pointing straight down. Well, whenever we create one of these tiny arrows, we turn it by this thing called the volley angle, and then we add another offset to it. So the volley angle here is like the middle one, right? Every time you have this set of 3, the middle one is going at the volley angle, and the ones before and after it are controlled by angle offset. But anyway, this part of, otherwise all the arrows have the same appearing logic. They all touch the player the same way, and this one has more variables. But yeah, all right, let's look back again at this to see how this is actually firing arrows. yeah, the crazy game has, despite its name, crazy game has way fewer variables than this. This pattern is pretty relatively complicated, I guess. So this here controls how it shoots out every 4 seconds. Let's slow it down a bit and we can see what's happening. So when this loop starts, we wait for a long cooldown divided by this variable here, the long cooldown divisor. And again, the boss will take this variable and increase it from 1 all the way up to 10. So at 1, long cooldown is unchanged, but at 10, you're only waiting for 10% as many seconds before you do this loop and fire bullets. So once that cooldown is done, we take angle offset. Now remember, whenever a bullet appears, it appears in this direction, which is facing the player, but then we add angle offset to it. So that's what this is going to do. The first bullet has an angle offset between -60 and +60, which means it can go in any random direction from like this way to this way. And then, so we make a clone, that's the bullet. We wait for short cooldown, which is 0.1 seconds. And then we fire another bullet, but the second bullet gets a random offset between -45 and +45. So it's starting to be more in the player's direction. And you can see as we go down here, the third bullet is only -30 to +30, which is like this, an even more narrow cone. And the fourth bullet from -15 to +15. So if you pay attention to the first 4 bullets that are going to come out of here, you can see well, I guess it's kind of hard to tell, but if we keep watching it, some of them go off really far, but the last bullet will always go in about a straight line. So let's go again. You can see that the last bullet is heading pretty much straight towards me almost. Here's one's coming straight towards me. So yeah, that's how these 2 flank ones up here and up here work. The only difference between these 2 is in these variables here. The right one has a speed of 4 and the left one has a speed of 3. That's the only difference. So the bullets coming out of the right one are slightly faster. That's it. And now we can look at the bottom 2. This is pretty, these I think are really cool. There's a lot of variables here, but we'll get to that. Okay, this is how this one works. Why the difference in speed? I wanted to. I think it's more interesting. I think because that way it's not just symmetrical. There's actually an advantage to being on one side versus the other. I don't know what that advantage is. Like I guess it's better to be on the left side, strong side, because that gives you more time slightly to react to bullets coming out of the right one, and those are the ones that go faster. So I guess the left is slightly better. But of course, you can't really stay, you can't really stay on the left side, because when the 2 bottom ones come your way, you probably want to move out of there. And another thing, if we start the game, you might notice, like if I go all the way over here, right? You'll notice that these bullets that go in random directions, they're mostly coming towards me, which means if I come over here, there's this giant empty void with no bullets in it. And see, now that I'm over here, I can go back, if I can thread the needle, and there's like no bullets over here. So if I just keep going back and forth like this, then relatively speaking, I have to dodge fewer bullets. The disadvantage is that I'm not really shooting the boss if I'm too far away. Like I have to stay under the boss, but yeah, see there's like, oh, got it. But you can see, so there is an advantage to moving, to like strafing back and forth. You kind of drag the random bullets with you, and that leaves a void on the other half of the screen. Excuse me. That's why these 2 here, that's where they come in. Every time you want to cross over the center, you got to go through these lines of bullets. And you can also see that, like, because they, start to come off in this direction, eventually that line of bullets is, it's going to come towards you. So yeah, it's pretty cool. I think there's a lot of like decision making going on, and I don't know, strats. Okay, let's talk about how these babies work. Now, let's start with whenever we make a clone, whenever one of these fires a tiny bullet. The speed thing is the same, just set it to the speed times the multiplier. Now the angle, all of them start facing straight down. And then we turn it by volley angle plus an offset. So the plus offset thing you can kind of remember from the top two arrows. But this volley angle, let's see what that's doing. There's actually two pieces of logic here. Let's start with this one, actually. So, you know what? I'm going to comment this. Turn angle. Or let's say turn angle back and forth. Okay. That's what this, so yeah, that's what this does. So let's see. So there's a bunch of variables we're using here. Angle increment is what we add to the angle, which you can see here, change angle by angle increment, change angle by angle increment. So that starts at 3, so 3 degrees. The angle starts at 0, which means no change. And angle increment interval, this is the number of seconds to wait. I think right now it's 0.1. It's kind of hard to see, but it's 0.1. And max angle range 60 degrees. Max angle range is pretty easy to explain. That's how far these things. So these little arrows here, see, they go to a max of 60 degrees. And you know what? Let's make this easier to see. Let's ramp up. I don't like how these comments keep jumping around, but let's see, where's my difficulty here? Let's ramp up the difficulty really fast. 0.1. And then you can see, I love the move. Okay, now you can watch it, right? And you'll see that both of these have the same maximum range of 60 degrees. So once it goes 60 degrees to the left, it starts going here, and then 60 degrees to the right. Sorry, Vlad, but I'm going to have to skip you so your words don't distract people. So you can see that they kind of sweep back and forth between negative 60 and positive 60. Or maybe it's the other way around. This is positive, I think, and this is negative. But yeah, that's what the maximum angle range is doing. And a cool thing is that you can kind of mess with this yourself. So you can change, if we change this to I don't know, 180, then we're going to see this left one that we just changed is going to go all the way up to the 180 before it turns around. See, like this. So yeah, there's a lot of stuff you can do with these variables. Yeah, see 180 and it turns back around. Hey, what's up, Pies? Thank you. I actually haven't hydrated in 2 hours. So I'm going to finish all my water. There we go. So check, I've been explaining the shoot 'em up here, kind of in the middle of it, because I wanted to highlight the explanation of my logic. But if you want to go back and see what's going on, feel free. So what I did here is I'm explaining this max angle range, and I just changed the left one to 180. Yeah, if you want to modify these variables, you can totally go nuts and... Oh, neat. Thanks. Thanks, Pies. I definitely needed that water. But yeah, if you want to play with these variables and see what they do, I definitely encourage it. That's one thing that I really liked doing when I first started making games. It was again, it wasn't with programming code. It was something, I guess, similar to this. And yeah, it was nice to just download other people's games and just mess with the variables, mess with other things, see what happened. There's so many things you can mess with here, and let's start talking about them. So let's look at what this code down here does. So we're in a loop here. And then there's two branches here. There's an if and an else. The top one here is if the increment is positive, and the else down here is if our increment is negative. If we're going in the positive direction, the only difference is that when we're going in the positive direction and increasing angle, this repeats until the angle reaches positive max angle range, it's positive 60. But if our increment is negative, which means our angle is decreasing, then down here, we're going to keep going until the angle is below negative max range, so below negative 60. And then in both cases, once we hit that limit, we set the increment to the increment times -1. So that's why it reverses direction, is these statements here that multiply the increment by -1. And when we're in these loops, we just wait for the increment interval, and every interval, we change our angle by the increment. We just add it. So yeah, that's how we get these to go back and forth. So this is, I think, like 3, and then it hits the limit, and it goes back to -3, and then it hits a limit, and it goes back to 3, and it's coming this way, and so on. So yeah, when I explain it, right, it's pretty simple when I explain it. And then, now this part, this is what's shooting the arrows out. So the first thing that happens, like I had with the top arrows, we've got a long cooldown divided by bullet long cooldown divisor that the boss controls. So this is one volley here. Hey, thanks for the follow, ATL_Roy. Welcome to the Cuckoo's Nest. If you're confused what's going on, I'm going to make a highlight of this whole part of the stream, and it's probably best to watch from the beginning so you can see what's going on. But I'm just explaining what these two bottom arrows are doing. Okay, so we talked about what the angle is doing. You can see that the angle here for this one is slowly, I think this is decreasing, going this way. Yeah. So let's see what's going on here. Each of these little groups of 3 is what's being fired here, little volleys of 3 arrows. The first thing we do is we're going to set volley angle to the angle. The reason we do this is that as this loop runs, we're still changing the angle down here. So what I want to do is I want to say, once this volley starts, I'm just going to take the angle that we're at and don't let it change. That's what volley angle is. So what would happen before I did this is that, like, the faster these turned, the more space there would be between, like, the little groups of arrows. So, none of that. I'm just going to take whatever the angle is and keep track of it as the volley angle. Same thing with the increment. So what would happen before is that when it would hit the end and turn around and start going the other direction, that increment reverses. And you would get, like, instead of a line of 3, when it reversed, you would get like a 1, 2, and then would come back. It's kind of hard to explain. But basically, volley angle increment, we're going to set them right at the start so that this loop down here is not going to affect them. So once we have those fixed, this is going to be our first bullet here. We set angle offset to the increment times -1. The first bullet is going to be slightly behind the middle. That's what you can see here. The first bullet is slightly behind. First bullet here, slightly behind. The middle bullet here. So we wait short cooldown again before we fire the middle bullet. Middle bullet just set the angle offset to 0. So you can see here, this middle bullet here, it's right in the middle. And the third one is wait short cooldown again and then set angle offset to the volley angle increment. So it's going to be a little bit ahead of the middle bullet. So you can see, like, here, the third bullet at the back is always ahead in the curve, here and here. So yeah, that's all that does. And that's how you get this effect. And that's why down here it turns, so the arrow starts pointing straight down and turns by the volley angle plus the angle offset. The angle offset is, the difference between these 3 arrows in each of these groups. So yeah, that's how these fire arrows. The only difference between the left and the right here, besides the fact that we changed this one to be 180 temporarily, I think the only difference is the angle increment interval. So the interval, again, is how quickly we add angle increment to angle. So here on the left one, every 0.1 seconds, we add 3 to the angle. But on the right one, every 0.07 seconds, we add -3 to the angle. So if I start the thing over again, you're going to see that the left one, we're adding +3, so it's going to go clockwise. And the right one, we are subtracting 3, so it's going to go counterclockwise. Let's see it. Yep, see, this is going clockwise, and this one's going, yep, and then it hits and then comes the other way. So yeah, that's one of the differences between the two. The other difference, again, is that this one has a smaller angle increment interval, so it basically turns faster. The right one turns faster than the left one. And that's why, well, if we look at it again, we're going to see that this one here on the right starts coming back to the left before the left one starts coming back to the right. And here again, this one making another boom before that one. Yeah. That gives it, again, it gives it more asymmetry. But I mean, you can always like get this game. Here, I'll copy the URL again. So you can go there, you can play the game for yourself. You can also edit the game. Let me think. Let me reset it back to what it was originally here. Change the difficulty so it doesn't instantly become super hard. There we go. So I think this is... All right. So we go shared C project page. So yeah, this is the project page. You can play the game here. And if you click this button here called See Inside, that will let you edit. It doesn't edit my copy of the game, but I think it will create a copy for you. And then you can go in and change whatever you want without affecting the game on my page. So if you ever like mess things up, you can just like not save it and then come back to my game page and get the fresh copy. So yeah, so you can feel free to just go nuts, change whatever you want, and it won't change my game at all. And you're also free to like, this is like a public game. Like I don't want any like copyrights or anything to it. So just go nuts. If you make something cool, it's yours. Just share it with people and just say, I made this. I mean, you could credit me, but if you forget, I don't care. Like this is a pretty simple, I'm going to be honest, like this is a pretty simple game. It's pretty cool though. It's pretty cool. I like it. But I'm sure like it's so simple that if you start messing with things, it's very quickly going to become your game and not mine. And I think you should definitely like share that with people and say, I made this. This is my boss butterfly. Yeah. But yeah, there's a lot you can mess with. Like I showed you can change the max angle range to make these things spin around. You can also just like, oh crud. Like instead of these direction reversing things, you could get rid of that and just have it spin around in circles. So that's another option. Old Godzilla was hopping around, skipping on to the next song. So see, there's a lot of stuff you can change here. And like their angle starts pointing down, so you could change that just over here to like something else. And then they'll sweep back and forth over here, or you can change it here and they'll sweep back and forth like this. Yeah. Let's see, you can change the sizes of the arrows, obviously, to make them bigger and more difficult to dodge. What about these top ones here? What could you change? You can change how this, like, there's basically infinitely many bullet patterns you can make with these. Like, I don't know, you just kind of got to use your imagination, I guess. Or, it's funny, there's two different ways that you can kind of be creative, I think, in situations like this. One of them is to have a vision of what you want to happen and try to make that vision happen in Scratch with logic. The other method is to do random stuff in Scratch and see what comes out. And I'm going to be honest, I use both of these methods. Like, sometimes I come in with a vision, and then sometimes I just come in and say, I'm going to do something and see what happens and see if I like it or not. And I think both approaches work well. And I think it's good to try both. So yeah, I guess that's the tutorial of how this game was put together. So again, I'll put a link to this. I guess if you're watching this on YouTube, it's going to be in the YouTube description. And I'll also link to my crazy game tutorial, which is like a simpler version of this basically. That's something else you can look at too if you want something that's a little bit simpler. But yeah, I guess that's it. So I hope people maybe learn something, and you know, again, feel free to modify these and call it your own. And you know, if you make something cool, let me know. I know that Aura wanted to add some bombs to Crazy Game, which I think would be cool. I think this game would be a nice one to have bombs into. Like, so you know, if you get cornered, you can press like spacebar or something and clear the bullets from the screen. That would be a pretty neat thing to add. Or you can add like a lives feature, so you don't lose when you get hit once. You got to get hit 3 times, you know, stuff like that. But yeah, guess that's it. So I hope everybody has a good rest of your day. I'm gonna head to sleep now. I'm gonna need some time before I can start making modifications. Yeah, definitely like take some time to play around in Scratch. Probably start. Oh, this should be invisible. Oh, it doesn't matter if it's invisible or not. It's just, yeah. It's the first thing these things do is hide themselves. But yeah. Hey, thanks, Pies. Thanks for coming by. Yeah. Okay, I guess I'll end it there. Thanks, everybody. Also, I'm gonna do a raid, but this is the end of the video, right? So I gotta pretend it's the end of the stream. So bye, everybody. Thanks for coming by. Hey, thanks, ATL Roy. Hope you have a good night too. And yeah, have fun.